Hello, we are looking at a recap on thermoregulation that we discussed in our earlier video, just to try and make things a bit more flexible. So thermoregulation, we are talking about thermo actually refers to heat. Okay, these are things that we didn't mention in our previous video. So this simply means we're talking about heat. Then regulation is just merely regulation is to control. Okay, to control. Okay, to control. So we're talking about heat and we're talking about controlling. So how this homeostasis works, what type of heat, why are we talking about heat? Okay, so we're talking about heat because of what we normally call as the body temperature. Okay, what we call the body temperature. So the body temperature of an animal, we talk about a human being, has been standardized. Optimum is 37. Optimum meaning this is the best. Okay, at this temperature your body will function very well. And we have things like enzymes that depend on the normal body temperature. Okay, so these depend on the normal body temperature. Okay, enzymes depend on the normal body temperature. If there is even a slight change, okay, either an increase or a decrease, these enzymes will malfunction. Okay, if the temperature is too high, the enzymes will actually be denatured. If it's too low, they won't be able to function. So the body temperature has to be around this degree, 37 degrees Celsius. But sometimes you find that even 36, maybe 36.5, maybe up to 37.5, all these can be considered normal. It's very close to 37. So now how does the body now control this? It does this by controlling the amount of heat that is inside the body. Okay, the amount of heat that is inside the body, and we're going to look at in a case whereby a situation where we have, let's say this is a human being. Okay, so now when we're talking about this being here, we can talk about two scenarios or two events. So let's say it's a very hot day. Okay, if it's a very hot day, what will happen? So if it's a very hot day, so you find that the temperature can go even up to 40, maybe it goes up to 45 degrees. So if the temperature outside is 45 degrees, we don't want this temperature to reach the body. We don't want the environment of the body inside to go to 45, because at this point it's way above that 7 degrees Celsius and most enzymes here will be denatured. So if it's a hot day now, the body now doesn't want to have this amount of temperature because it keeps on getting hot. So what does the body do now in order to cool itself off? Okay, because it's hot outside, the skin becomes hot and the body needs to cool itself off. So there are certain things that the body will do, and one of them is that you notice that you will begin to sweat. Okay, you will begin to sweat. Now when you begin to sweat, what is happening here? You see, this is the structure of the skin. It's been magnified. Imagine this is just one strand of air. So the sweat comes out here through the sweat. So you have a sweat duct, okay? These are sweat glands that release sweat. So now these are sweat pores. So the sweat actually comes here when you begin to perspirate, okay? So you find that you begin to sweat, okay? So now what is happening when you're sweating? As the sweat is coming out, it is releasing some heat to the surrounding, so that your temperature inside your body doesn't go um, it doesn't go beyond 37 degrees Celsius. Okay, so it will make sure that you begin to do what, to sweat. Okay, so that's the first thing that's going to happen here. So that heat is released, so that the body remains cool. So the body is trying to cool itself. It doesn't want to adapt to this temperature which is outside. Okay, so the other thing that will happen is that there will be what we call vessel. We talked about this. There will be what we call vessel. So vasodilation. Okay, so there will be what we call vasodilation. Now, this vasodilation, vessel means the blood vessels. What are they going to do? The blood vessels, they will dilate. What is to dilate? They widen. So you see the way these blood vessels are, they widen like this. Okay, they widen. Okay, the blood vessels would definitely widen. So the way they are like this, they're a bit thin, but they widen. Why are they widening? So that as the blood flows, heat can simply be lost to the surrounding. Okay, so the blood vessels here. So when you talk about vasodilation, we're talking about these blood vessels. And then the other thing is that the shunts will be open. Okay, these the shunt vessels will be open to shunt blood. Shunting blood simply means oh, so sorry, here they won't be open. The shunt vessels will close. Okay, shunt vessels will definitely close. Okay, so here blood won't be able to pass here to close up, so that it goes here and then the heat is lost. So all in all, we're just simply trying to lose heat, but the body remains cool. Okay, then the fourth one, what's going to happen is that the hair, you notice that the hair now will remain flat. If you notice, most of the times this hair won't be standing the way it is. The hair will just remain flat. So what pulls it is this muscle called the air erector muscles. Okay, so the air erector muscle, okay, we can say that the erector muscle, the erector muscle, the erector muscle will do what? Will relax. Okay, the erector muscle will relax, and once it relaxes, what happens? The air, okay, air will lay down. Okay, will lay onto the skin. Okay, this air will just be laying on the skin. So this is what will happen. So heat, you find that if it's laying there on the skin, you have some heat being released there, okay, to the environment. Okay, so this is what will happen on a hot day. Now, what's going to happen now? Let's say the temperature now, let's say we are in a very cold season. Okay, let's say we're in a very cold season. I'm going to remove this. We're changing the scenario. We change the scenario here. So if we are in a cold season, let's say it's very cold. Okay, it's very cold, and this is our person here, a very cold season. And then you notice that when it is cold, let's say the temperature goes as below as maybe 20 degrees Celsius. Okay, it's so cold. And then what will happen now? We don't want our body temperature to also become 20 degrees Celsius. So the body has to make sure that this heat, okay, sorry, let me draw it inside here. Just to make sure that the heat inside the body is maintained. It should not escape, okay? It should not escape away. The heat needs to be maintained so that the body will be warm, okay? So the first thing that we'll talk about here is that the body will make sure that there is what? No sweating. You shouldn't sweat when it's cold, because sweat comes out with heat and we don't want the heat to be released, okay? So there will be no sweat. So what happens is that these sweat pores, they just close up, so you won't be able to sweat, okay? Then the other thing that will happen, there will be what we call vasoconstriction. Now vasoconstriction is the thinning of these blood vessels. Remember we said the blood vessels, and when it's hot they will become big, but now here the blood vessels will become very thin, okay? They will become very thin like this, so that blood does not flow up to this side, okay, because heat will be lost. And these shunt vessels, they will open, so find that blood, instead of reaching here, it will shunt itself like this, and then it can go back, okay? So blood will just, okay, so that is the other thing. 3 is that the shunt vessels will open, okay? The shunt vessels will open. The fourth one, very important here, what's going to happen, we'll talk about this erector muscle. What will happen to this erector muscle? It's going to contract. The erector muscles will contract. Once they contract, they pull this, okay, and this is also pulled. What will happen? This hair strand will stand upright. Now imagine you have a lot of hair standing upright. Now the hair on the skin, sometimes you can't see it, it's too thin, but what can notify you that the hair follicles or the hair is standing upright on your skin is when you see what we call goosebumps. You notice when it's very cold, you come out these goosebumps, okay? Goosebumps. So now when the hairs are standing like this, they will trap air here, which will cover your skin like a blanket, so that heat is not lost, okay? So this is what happens during the time when it's cold, time when it's hot, okay? So you need to know this. That is how thermoregulation takes place. So this is how the temperature in the body is maintained, such that it's somewhere around this. When it's cold, at least we can expect your temperature to be 6.5 something, 6.7 something, okay? Just like this, it means that you are just good. Okay, so this is just a simple explanation here. I hope it's been helpful. Watch the previous video as well, where we discussed about these things, okay? We discussed homeostasis introduction, and we also talked about thermoregulation, okay? So I'll meet you in the next video as we continue looking at homeostasis.